How does feature union enhance a machine learning pipeline? A. It allows you to apply different feature extraction methods to distinct subsets of your data, combining the results. B. It transforms features into a new representation, example PCA, or polynomial features. C. It scales features to a common range, preventing one feature from dominating others. D. All of the above. True. This is a key benefit of feature union. You can use different feature extraction methods on different parts of your data, like TF-IDF on text and Word2Vec on another portion, and combine the results into a single feature vector. This allows you to leverage the strengths of different methods for a more comprehensive representation. Example: imagine you have a dataset with both text and numerical data. You can use TF-IDF to extract features from the text and a standard scaler to pre-process the numerical data. Feature union allows you to combine these features into a single representation, which can then be used to train a machine learning model. Combining diverse feature extraction methods. True. Feature union can also be used to transform features using methods like PCA, principal component analysis, or polynomial features. PCA can reduce dimensionality while preserving important information, while polynomial features can capture nonlinear relationships. Example: in image classification, PCA can be used to reduce the number of pixels in an image, while polynomial features can be used to model complex relationships between pixels. Feature union allows you to combine these transformations, creating a more expressive representation of the image data. Transforming features for improved representation. True. Feature union can also handle feature scaling. Scaling features to a common range is crucial for many machine learning models, as it prevents features with larger scales from dominating the learning process. Techniques like standard scaler and min-max scaler can be included within a feature union to ensure features contribute equally. Example: in a regression problem where some features are in the range of 0 to 100 and others are in the range of 0 to 1, standard scaler or min-max scaler can be used to scale all features to a similar range, ensuring they have equal influence on the model's prediction. Scaling features for balanced influence. True. Feature union is a versatile tool that allows for combining different feature extraction methods, transforming features into a new representation, and scaling features for balanced influence. All of the options are valid ways in which feature union enhances machine learning pipelines. Feature union, a versatile tool for data preparation. D. All of the above. Feature union, a powerful tool for combining features in machine learning. Machine learning pipelines. Feature extraction. Feature transformation. Feature scaling. Pipeline sklearn.pipeline.pipeline. Standard scaler sklearn.preprocessing.standard scaler. Min-max scaler sklearn.preprocessing.min-max scaler. PCA sklearn.decomposition.pca. Polynomial features sklearn.preprocessing.polynomial features. TF-IDF sklearn.featureextraction.text.tfit vectorizer. Word2Vec gensym.models.word2Vec. Feature union sklearn.pipeline.feature union. Text analysis combining TF-IDF and Word2Vec to capture both lexical and semantic features. Sentiment analysis of customer reviews. Feature union can be used to combine TF-IDF, which captures the frequency of words, with Word2Vec, which captures the semantic relationships between words. This combined representation can provide a more comprehensive understanding of the sentiment expressed in customer reviews. Image processing, combining PCA and polynomial features for dimensionality reduction and capturing nonlinear relationships. Image classification of medical scans. Feature union can be used to combine PCA, which reduces the dimensionality of the image data, with polynomial features, which can capture complex relationships between pixels. This combined representation can improve the accuracy of image classification models, leading to more reliable diagnoses. Regression with mixed data types, scaling numerical features and applying one-hot encoding for categorical features. Predicting house prices. Feature union can be used to combine scaling techniques for numerical features like square footage and one-hot encoding for categorical features like the number of bedrooms and bathrooms. This ensures all features contribute equally to the model's prediction, leading to more accurate estimates of house prices. What is the primary purpose of using a pipeline in sklearn? A. To simplify the process of building and evaluating machine learning models. B. To optimize the hyperparameters of a machine learning model. C. To transform data into a suitable format for machine learning algorithms. D. All of the above. 1. Simplicity in model building. True. A pipeline streamlines the model development process by combining multiple steps into a single object. Example: transforming data, feature selection, and training a model can be combined within a pipeline. 2. Efficient hyperparameter tuning. True. Pipelines allow you to optimize hyperparameters of multiple steps simultaneously using tools like grid search CV, simplifying the tuning process. Use case fine-tuning both the pre-processing steps and the model's parameters for optimal performance. 3. Streamlined data transformation. True. Pipelines can include data transformation steps like scaling, encoding, and feature engineering, ensuring data is ready for the model. Example: applying standard scalar to standardize features before training a linear regression model. Answer D. All of the above. True. Pipelines offer all these benefits, making them a powerful tool in sklearn. It's a combination of the benefits from choices A, B, and C. D. All of the above. Pipeline. A pipeline in sklearn is a powerful tool for streamlining machine learning workflows. It allows you to combine multiple steps, transformers and estimators into a single object. Transformer. A transformer in sklearn is a class that implements the fit and transform methods. Estimator. An estimator in sklearn is a class that implements the fit and predict methods. Grid search CV. Grid search CV is a hyperparameter tuning technique that systematically explores a grid of parameter values to find the best combination for a given model. It is particularly useful for optimizing the performance of pipelines, as it allows for simultaneous tuning of multiple steps. Cross-validation. Cross-validation is a technique used to estimate the performance of a machine learning model on unseen data. It involves splitting the data into multiple folds and training and testing the model on different combinations of folds. Standard scalar. Standard scalar is a data pre-processing technique that scales features to have zero mean and unit variance. This can be helpful for improving the performance of algorithms that are sensitive to feature scaling. Linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. What is the primary advantage of using sklearn.pipeline.make pipeline in machine learning? A. Simplifies model building and prevents data leakage by automating the sequential application of transformations and estimators. B. Improves model performance by automatically selecting the best hyperparameters for each step in the pipeline. C. Enhances model interpretability by providing detailed insights into the individual transformations applied to the data. D. All of the above. A. Simplifies model building and prevents data leakage by automating the sequential application of transformations and estimators. This choice is correct. Make pipeline streamlines model building by automating the application of transformations, example scaling, encoding and estimators, example linear regression, random forest, in a sequential manner. This prevents data leakage because transformations are applied only once to the entire dataset before reaching the estimator, ensuring that the estimator is trained on transformed data and not the original raw data. Data leakage. B. Improves model performance by automatically selecting the best hyperparameters for each step in the pipeline. This choice is partially correct. Make pipeline makes it easier to perform hyperparameter tuning using techniques like grid search CV or randomized search CV, which can improve model performance. However, it doesn't automatically select the best hyperparameters. You still need to define the search space and use these methods to find the optimal hyperparameters. Hyperparameter tuning. C. Enhances model interpretability by providing detailed insights into the individual transformations applied to the data. This choice is partially correct. Make pipeline itself doesn't directly enhance interpretability. However, by organizing your pre-processing and modeling steps in a pipeline, you can more easily inspect the individual transformations and their effects on the data, which can contribute to understanding the model's behavior. Model interpretability. D. All of the above. This choice is correct. Make pipeline simplifies model building, helps prevent data leakage, and facilitates hyperparameter tuning. While it doesn't directly improve interpretability, it makes it easier to understand the model's behavior by organizing the transformations. Core concepts.
D. Data leakage. Data leakage occurs when information from the test set, the data used to evaluate the models, performance, is accidentally incorporated into the training data. This results in an overly optimistic performance evaluation because the model is essentially cheating by using information it should not have access to during training.
As the model is using information that wouldn't be available in real-world scenarios. Transformations. Transformations are operations applied to the data to prepare it for the machine learning model. Common transformations include standardization, scales data to have zero mean and unit variance. Feature scaling brings features to a similar range, preventing features with large scales from dominating the learning process. Imputation fills in missing values in the data using strategies like mean imputation or k-nearest neighbors. Estimators. Estimators are the machine learning algorithms that learn from the data and make predictions. Examples include Linear regression finds a linear relationship between input features and the target variable. Random forest combines multiple decision trees to make predictions, reducing the risk of overfitting. Hyperparameter tuning. Hyperparameters are parameters that are set before training a machine learning model. These parameters control the learning process and the complexity of the model. In a random forest model, the number of trees estimators is a hyperparameter. Tuning this hyperparameter can significantly impact the model's performance. Model interpretability. Model interpretability refers to the ability to understand how a machine learning model makes predictions. A more interpretable model is easier to understand and trust, as you can see how the input features influence the output. A simple linear regression model is highly interpretable because you can directly see the coefficients of each feature, indicating the strength and direction of their relationship with the target variable. Use cases. Pipelines are incredibly versatile and can be used in various machine learning tasks. Pre-processing pipelines can standardize data, handle missing values, and encode categorical features. Feature engineering pipelines can create new features by combining existing ones or applying domain knowledge to extract relevant information. Model selection pipelines can automatically evaluate different models on a given dataset and choose the best performing one. Model evaluation pipelines can perform cross-validation to estimate the model's generalization performance and tune hyperparameters. Which of the following statements are true regarding sklearn pipelines? Make union. A make union allows combining multiple transformers into a single transformer. B. Make union operates on the same input data across multiple transformers. C. Make union allows parallel execution of transformers. D. All the above. This statement is correct. The make union functionality allows the combination of multiple transformers into a single transformer, which is crucial for streamlining pre-processing steps, ensuring proper execution order, and enhancing data consistency. Make union in sklearn pipeline acts as a way to combine multiple transformers into a single one. This means it effectively allows you to use multiple pre-processing steps simultaneously on the same input data. By creating a single composite transformer, you can ensure all your pre-processing steps are applied in the correct order, resulting in clean and ready-to-use data for your model. This statement is correct. Make union applies the same input data to all the transformers within the union. This ensures consistency across different transformation steps, leading to a unified, coherent pre-processing process. Make union in sklearn pipeline acts as a way to combine multiple transformers into a single one. This means it effectively allows you to use multiple pre-processing steps simultaneously on the same input data. By creating a single composite transformer, you can ensure all your pre-processing steps are applied in the correct order, resulting in clean and ready-to-use data for your model. This statement is correct. Make union permits parallel execution of the transformers it combines, enabling faster pre-processing. The parallel nature of this process significantly reduces the overall time required for data preparation, making it more efficient. Make union works by allowing transformers to run in parallel on the same input data. This parallel execution significantly reduces the time taken to apply multiple transformations. This statement is correct as all the preceding statements have been proven correct through the analysis. All the above. D. All the above. A pipeline in sklearn is a sequential workflow that chains multiple data processing steps transformers together. This creates a unified process for transforming and fitting data before applying a final estimator, example, a machine learning model. Imagine you're building a model to classify customer churn if they will leave your service. You need to pre-process the customer data, which might involve converting categorical variables to numerical ones, scaling numerical values, and then applying a decision tree model. A pipeline streamlines this entire process, ensuring consistency and efficiency. A transformer in sklearn is a specific type of estimator that learns a transformation from data. It modifies the data by applying a defined set of rules or operations. It is primarily used for pre-processing or feature engineering. One common transformer is standard scaler. It scales numerical features to have a mean of 0 and a standard deviation of 1. This is essential for algorithms that are sensitive to feature scale, like k-nearest neighbors KNN. In a churn prediction model, you might standardize income and age to ensure they contribute equally to the model. An estimator in sklearn is a general term for any object that can learn from data. This includes transformers, classifiers, regressors, and more. Estimators have the ability to learn from data by fitting a model based on the provided training data. A logistic regression model is an example of an estimator. It learns a relationship between independent features and a binary outcome, example churn or no churn. The model can then predict whether a new customer is likely to churn based on their attributes. Feature union is a transformer in sklearn that combines the output of multiple transformers, applying them in parallel on the same input data. This lets you create more complex feature engineering pipelines by combining the benefits of different transformations. Let's say you want to extract features from text data using both bag-of-words BAU and TF-IDF techniques. You can use feature union to apply these two transformations independently and concatenate the resulting features. The combined features can then be used to train a model for sentiment analysis or topic classification. Column transformer in sklearn is a powerful transformer that allows you to apply different transformations to specific columns of a dataset. It's especially useful for datasets with mixed data types, example numerical and categorical columns. In a churn prediction model, you might want to perform one-hot encoding on categorical variables like customer type while scaling numerical features like age and income. Column transformer lets you apply these distinct transformations to their respective columns, streamlining the pre-processing process. 25, 32, 41, 28, 35. 50,000, 65,000, 78,000, 55,000, 70,000. Male, female, male, female, male. Consider a simple dataset with 3 features: age, income, and gender. We want to prepare this data for a machine learning model. Column transformer will use column transformer to apply different transformations to the numerical columns age, income, and the categorical column gender. Apply standard scaler to age and income to normalize their scales. Apply one-hot encoder to gender to convert it to numerical values. Make union will combine the output of standard scaler and one-hot encoder using make union. This ensures all features are on the same scale and represented numerically, ready for the model. Pipeline well chain the column transformer and the make union within a pipeline. This creates a sequential workflow for pre-processing the data before fitting the final model. You are building a machine learning pipeline for a dataset with both numerical and categorical features. You want to apply different transformations to each type of feature. Which of the following is the best way to utilize make union in this scenario? Use make union to combine different feature extraction methods for numerical features. Apply make union to combine different imputation techniques for missing values in categorical features. Use make union to create separate pipelines for numerical and categorical features and then combine their outputs. Use make union to concatenate multiple target variables before passing them to the final model. Incorrect. While make union can combine transformers, it's not specifically designed for combining different feature extraction methods within the same feature type. It's more about combining transformations across different subsets of data. Incorrect. Similar to choice A, make union is about combining transformations applied to different parts of the data, not necessarily within the same feature type. Correct. This accurately reflects the primary use case of make union. You would build separate pipelines for numerical and categorical data, each with appropriate transformations, and then use make union to merge their outputs for the final model. Incorrect. Make union deals with feature transformations, not target variables. Concatenating target variables is usually done at a different stage of the machine learning process. Font style font size 14 ps. Use make union to create separate pipelines for numerical and categorical features and then combine their outputs. Font. A pipeline in machine learning is a sequence of data transformation steps and a final estimator model that streamline the workflow. It helps to automate and organize the process, ensuring consistency and reducing the chances of errors. Imagine you're building a model to predict house prices. You might have a pipeline like this. 1. Data cleaning, removing missing values or outliers. 2. Feature engineering, creating new features like the ratio of bedrooms to bathrooms. 3. Feature scaling, standardizing numerical features to have a similar range. 4. Model training, using a linear regression model to learn the relationship between features and house prices. Make union is a pipeline step that combines the outputs of multiple independent transformers. It allows for different feature engineering or transformation steps to be applied to separate portions of the data. Consider a dataset with both numerical and categorical features. 1. Numerical pipeline, you might apply scaling and imputation to numerical features. 2. Categorical pipeline, 1. Hot encoding might be used for categorical features. Make union would take the outputs of these two pipelines and combine them into a single dataset, ready for the final model. Make union is a versatile tool that can be used in various machine learning scenarios. Combining different feature extraction methods applied to different types of features, example PCA for numerical and TF-IDF for text data. Handling datasets with diverse data types, example images, text, numerical, by applying distinct transformations to each type. Separating pre-processing steps for datasets with mixed features, example scaling for numerical and 1 hot encoding for categorical. Creating custom transformer combinations tailored to specific needs by combining multiple transformers.